welcome to this episode of the Red Mic Podcast. I'm excited today to be talking about a topic that many of you ask me about and want to know more about, and that is the subject of creation. Creation, what does the Bible say? What does science say? How do we interact on this important topic? And I am excited to have a guest on today's podcast. I am joined by Dr. J. Wile, and I'm going to bring him on the screen here. Thank you for joining us, Dr. Wile. Tell us something about yourself.
Well, something fun about myself is that I used to be a professional actor. I still do acting for fun, but that was how I actually started my career as a professional actor. Then I
Wow.
went to college and got a PhD and all that.
Well, so
So,
that sounds like less fun, but maybe more helpful to our conversation here. And so,
well, actually, my PhD was very fun. So I went into chemistry at the university level because in the theater, the special effects that I did were based on chemistry. So I thought, oh, I'll study chemistry. I got fascinated with the nucleus of the atom and how these protons stay together despite the fact that they want to repel each other. And so I went into nuclear chemistry, and that's what I got my PhD in. I know a lot about the nucleus and how the protons and neutrons interact, radioactivity, and all of that. And I did basic fundamental research for quite a few years and was a professor. But then I tried my hand at writing books, and it turns out my textbooks got popular among homeschoolers. And so I started trailing off my scientific research and being a professor and spending more time writing until I'm now just full time. And I've been full time writing since 2000.
wow. And so I was actually homeschooled. So I was raised, as far as my science curriculum was on your textbooks. For middle school and high school, I was raised on your textbooks. And now, one of the organizations I oversee, we have several schools, and we use Berean builders for our textbook in most of those schools at most of the different grade levels, because Berean builders, and maybe Apologia did and I didn't know back in the day, but Berean builders goes much lower in age than I believe Apologia did.
Well, Apologia went all the way to K, but I didn't write the K through 6 stuff. Someone
Got
else
it.
wrote the K through 6 stuff. In Berean Builders, I went ahead and wrote K through 6 as well as all the high school stuff.
Got it. Well, what does your work entail right now as it relates to creation? Do you write on creation, speak on creation? Is it more of a hobby that you study? Tell us about that side of things.
Well, I do speak about it quite a bit. As a matter of fact, if I think about, the public lectures I give the most, that they are creation evolution lectures. I write about it, but in the context of my textbooks. So when you study physics, you study certain aspects of the physical world, and there are aspects of the physical world that make it look very young. When you do biology, you study histology, which is the structure of tissues, and because of that, we know that we can find bone cells that aren't even fossilized yet in dinosaur bones. And if you can find soft bone cells in dinosaur bones, that tells you those bones aren't millions of years old. So when it relates to the subject in my textbooks, I bring it up.
Okay. And so it would be fair to say that most of the textbook is not directly related to the creation evolution debate, but
Oh,
the
definitely.
information, when it's relevant to the subject, is brought out in the textbooks.
Yes, because I honestly, to this day, think if you really want to defend the Christian faith, the best way to do it is not to get a degree in apologetics. It's to get a degree in an academic field and learn that academic field real well and apply that to apologetics. So I'd rather produce students who are good chemists, physicists, biologists, let them become good at that field and let them apply that to the creation evolution debate or any kind of apologetics you're doing.
Yeah, that's fair. I suppose, especially as it relates to research and advancements, it would be
Mhm.
necessary for them to actually be in those fields and not just
Right.
memorize or learn information in a bunch of fields.
Yeah, exactly. And honestly, if you think about who are the best apologists out there, they are generally the people who have their degrees. I mean, William Lane Craig, for example, has got a PhD in philosophy, not in Christian apologetics,
Yeah.
right? And so, and like, uh, who's the John Sanford, Dr. John
Yep.
Sanford. He's one of the best voices in young Earth creationism. He has his PhD in genetics.
Yep.
So I think that's the way you do it.
Good. Well, let's talk about the scientific community at large. So, when we're dealing with the creation evolution controversy, obviously people will notice that most practicing scientists tend to be on the side of the earth is billions of years old and evolution is the means by which life came about, which may include God or may not include God, but nonetheless they would tend to believe in evolution. Why do you think that is?
Well, I think there are three big reasons, and it depends on what branch of science and what kind of science you're doing as to which is the main one. So, like for example, my PhD advisor is an atheist, and he and I used to have discussions all the time. And he said, "Look, even if a bunch of explorers climbed Mount Everest and found the Ark, you could still not scientifically believe in the global flood story because science cannot allow for miracles." So
Um,
there is a group of scientists who say science can't allow for miracles, even if the miracles happened.
so it's just a
So science,
presupposition.
yeah, but the key is science isn't a search for truth; it's a search for a model, and you can't model a miracle. So in the end, you have to come up with something that can be modeled, and if it can't be modeled, by definition, it's not science. Now, to me, that's an absurd claim. Science has always been trying to figure out exactly how the universe works, exactly how the earth works. And if that includes miracles, then you got to take it, right?
Yeah.
But nevertheless, there is a group, and for some scientists, that's the big thing. For other scientists, I think it's what you said, the presupposition. There are lots of scientists who simply don't want to believe in God. And that was, one of the, especially for the age of the earth, the first reason we got into talking about millions of years was specifically because of people like James Hutton, who was a geologist in the 1700s, I think, who basically said, I don't want the Bible to be guiding my science. So
Mm.
I don't want to believe in a flood. So I've got to come up with some other explanation. And so if you don't want to believe in God, then you've only got a naturalistic explanation. And of all the naturalistic explanations, then yeah, evolution and long ages is your best option.
Yeah.
I don't think it is the best, but it's your best option if you want, if that's your goal.
Yeah.
And then the third reason, which I think is more applicable to younger scientists, as scientists get older, they get a little more, and I've seen this in my own life. When I was younger, I was much more likely to go along with the scientific mainstream because I thought, how could all these scientists be wrong? The more science I did, and the more science I actually did, and the more scientists I actually worked with, I came to realize, yeah, scientists can be wrong a lot, even the majority. So
Yeah.
I think that, scientific consensus is a big deal to uninformed people and to young scientists.
Yes.
So in the end, I think those are your three big reasons.
Now, without rabbit trailing too much, how big of a reason do you think fear of pushing back against consensus plays into this equation?
Well, I think for younger scientists it plays a big role.
Okay.
When I was getting my PhD, you have a committee of professors who judge your PhD thesis. Your PhD advisor basically is the one who says, but you've got these other four professors. One of those professors on that committee said, "I will not grant a PhD to a young Earth creationist. Period.
Mm.
Doesn't matter what his thesis is on. So unless he changes his mind, I'm not going to grant him his PhD." Some young scientists would say, "Well, I need my PhD, so I'm gonna change my mind, or at least publicly change
Yes.
my mind." Right?
Yeah.
My PhD advisor, though he was an atheist, he was also ethical, and he
That's
realized, look,
helpful.
yeah, we judge a PhD candidate based on the quality of his thesis and his defense of the thesis. So
Yes.
he actually got that professor removed, and another professor was put in his place. So I think the more vulnerable and the younger a scientist is, the more hesitant they are to push against the consensus. I wasn't worried because I had this idea that God's going to take care of me as long as I'm trying to genuinely search for Him.
Yeah.
So but a lot of scientists who are Christians will just either not talk about it at all, or will do as little as possible until they get tenure. Then when they get tenure,
That's
they're
right.
freer to talk about these things. I didn't care about getting tenure, and as a result, I never did get tenure.
Yeah.
So
Now, so it would be fair to say that in some way, the reason why so many people believe in this is because they are pressured, taught. I mean, that's just what people, the system they go through produces people who believe in it.
yes, that's
Okay.
certainly true, and I think that's one of, if I, especially for younger scientists, I think that's the
Okay.
predominant reason.
Yeah. Now, is it possible? You already gave an allusion to this answer, alluded to the answer. Not just is it possible, is it common that the majority of consensus in science, right, the majority opinion can be wrong?
Oh, in fact, the more likely scenario for any given subject is that the consensus is wrong. And the history of science tells us that. I was talking to a colleague of mine about this. He's a PhD engineer. And he was like, you could argue that the scientific consensus is always wrong about something.
Yeah.
And that's really true because in the end, science is based on experiment. Experiment can be flawed. So what we thought was absolutely true, even 10 years ago, we now know is false. And it doesn't matter how long that consensus has been around. There have been scientific facts that have stood the test of 500-600 years that then suddenly fall to the data.
Yes.
So yeah, scientific consensus is more often wrong than right.
And sometimes it's what the minority was saying for 100 years that ends up being correct, not something completely new.
Yeah, absolutely.
All right.
And it's not like this happened in the past. This happens continuously. Everybody thinks, okay, yeah, the past science was inexact and all of that. And now that we've got good technology and good science, we're not making mistakes anymore. Oh no, we're still making mistakes, lots of them.
And
And we find that every year.
even within the secular realm, even on these subjects, they keep having to change the story in minor ways all over the place.
Oh, sure.
And I don't keep up with it probably as well as you do, but just the theory of evolution in general, I'll see headlines, wait, mankind existed way before we thought he existed. I mean, they just keep changing things and keep having to update the theory.
And there's nothing wrong with that.
Correct.
Because, in fact, that's the way science works. It is
Yep.
self-correcting. What's wrong is when people talk with certitude about science.
Yeah.
When anyone talks with certitude about science, I can guarantee you he or she's not a good scientist. Because scientific statements must be tentative by their nature.
Well, so let's move then to the subject of creation, evolution, and let's kind of zoom in on the age of the earth debate. So, setting aside the argument that, well, the majority believe it, so it must be true, knowing that the majority can be wrong, as a scientist, give us a couple arguments that you think demonstrate the earth is young.
Okay, well, let me start by saying that an old Earth is one of the worst scientific positions you can hold, simply because it breaks the rule that every scientist learns very early on about extrapolation. If I'm following the trend of the data and I follow it for, say 10 years, I can assume that trend continues for another year. But the longer I'm trying to assume where that trend continues, the worse a conclusion it is. So if I've got 10 years of data, I can extrapolate it to the next 6 months or a year and be pretty confident. I wouldn't extrapolate it to 100 years. That's
Yeah.
simply scientifically irresponsible. In believing the Earth is billions of years old, we're taking stuff that we've studied for just a little over a year and we're extending it over billions of years. That's one of the most scientifically irresponsible things you can do. So even when I believed the Earth was old, I was very tentative about it because as in my analytical chemistry days, this rule of extrapolation was pounded into my head.
Okay.
And I think that's one reason I was more likely to become a young earther, because I was initially skeptical of old Earth simply because of the bad science that it is.
Now,
But in terms of
pause right there. You at one point did believe the Earth was billions of years old.
yes, yeah,
All right.
Early on, before I was actively getting my PhD, when I was still working on my master's, I was an old earther because I didn't have a problem with it.
Yeah.
And it's what I was taught. Right.
Okay.
So to me right now, the two strongest pieces of evidence for a young Earth, the first one has been around for a long time, and that's there's only one working model of planetary magnetic fields. and it is a young Earth model that requires the Earth to be less than 10,000 years old. This model was used to predict unknown things before they were discovered. So when the model was written, we didn't know what the magnetic fields of Neptune and Uranus were. However, Voyager was flying out, so eventually they got there. So several years before they got there, the guy who wrote the model said, look, once we measure it, Uranus is going to have this magnetic field, Neptune is going to have this magnetic field. Well, the old Earth model also made predictions. Those predictions were 10,000 times wrong. They were off by a factor of 10,000. The young Earth prediction was right on the money. And since then, the young Earth prediction, the young Earth theory of planetary magnetic fields has made other predictions about data that were not known. And when those data were measured, the young Earth theory was once again vindicated. To me, that's the strongest argument. When you can develop a model that predicts something we don't know, and then you go measure it and you find out the prediction is true, that gives you a lot of faith in your model. Well, one of the things this model requires is a Earth that's under 10,000 years old. So to me, that's the strongest bit. More recently, though, as a nuclear chemist, the best evidence, the second best evidence for the young Earth, is the fact that we found in every dinosaur bone or every piece of coal or every diamond ever tested, we found carbon-14. Carbon-14 is a short-lived radioisotope that should decay away in 50 or 60,000 years. These dinosaur bones are supposed to be millions of years. Coal's supposed to be hundreds of millions of years. Diamonds are supposed to be billions of years old. And yet, they all have carbon-14 in them. That indicates they can't be billions or millions of years old. They can only be multiple tens of thousands of years at best.
Now, so going to the magnetic field theory first, if I can ask a few clarifying questions. Sure. So the model requires the Earth and the solar system, I'm assuming, to be young in making these predictions about these different planets. It accurately predicts the Earth as well. Where did that model come from?
Well, I have to, models all have to have parameters fixed, right? So we have to calibrate all of our models. Every model's like that. So both the young Earth and the old Earth magnetic field model uses Earth as a calibration.
Got it.
Right? So then once they fix the parameters using Earth as a calibration, then they predict the other planets.
And if they predict them right, then they probably have Earth right as well.
Yeah, exactly. Right. Okay. So this was done in the 80s by a nuclear physicist named Russell Humphreys. And he wrote a paper that was published in the Creation Research Quarterly, and it was called On the Creation of Planetary Magnetic Fields. And he develops this mathematical model based on a verse that he reads a particular way. I think it's 2 Peter 3:15, something close to that, where it says the earth was made of water and by water. So he says the way God started fashioning each planet was he started with a ball of water that had the mass of the planet. And then miraculously, of course, he transmutes the water into all the other elements that make up the actual planet. Well, when that happens, if that were to happen, water has a magnetic field. You get rid of that magnetic field by making these other elements. In the presence of a conductor, and the core of the Earth is a conductor, you have a varying magnetic field in a presence of a conductor that produces an electronic current. Electronic currents produce magnetism. So he came up with this idea, and once again, he developed a model of how that would work, used Earth as a calibration, and then looked at all the other planets. And you have to understand, the old Earth model wasn't even right about whether or not a planet had a magnetic field. Oh. Because before we sent Viking out to, or was it Mariner? I think it was Mariner, out to Mercury, we almost didn't put a magnetometer on it because the old Earth model said Mercury shouldn't have a magnetic field. But it turns out magnetometers are light and pretty cheap. And so they put one on, and sure enough, Mercury had a magnetic field. Well, the young Earth theory shows why it has a magnetic field. The old Earth theory is still baffled as to why Mercury has a magnetic field. Young Earth theory isn't.
And I remember actually, I don't know what year it was, maybe 2013, 2014.
Oh, yeah.
When they were putting predictions out for maybe the more detailed estimate of what Mercury's magnetic field would be. I remember something about that actually when I was a young adult, and remember following Humphrey's model and its predictions on that. And so all of that
And
requires.
it fared better than the old Earth model.
Yeah.
Even in the more recent test, 2005.
And if his model accurately predicts everything, if it's the best model, it's a model that requires the Earth to be young.
Yes.
All right.
Exactly.
And then the second piece of evidence was carbon 14. Is it possible that something can put carbon 14 into coal or diamonds and it's not original to the element?
With diamonds, that's hard. It's
Okay.
really hard to understand how anything could get into a diamond, carbon 14 or anything else. Now, with fossils and with coal, absolutely. But there's a really easy way to test this, especially like a fossil. A fossil is encased in rock, and there's some carbon in that rock. So if carbon 14 entered the fossil, you should measure more carbon 14 on the outer part of the fossil than on the inner part of the fossil.
Yeah.
Right? So there should be a definite gradient, more carbon 14 outside, less carbon 14 inside. You don't see that pattern at all. You see a very consistent
Oh.
reading. I mean, they always vary a little bit, but there's no pattern to it. In some fossils, there's more carbon 14 on the inside, and other fossils, there's more carbon 14 on the outside. But it's all very small variations.
And if
So in the end, there's no pattern.
if every fossil just happened to be infected with carbon 14 from outside, you should see at least some pattern.
Yes, exactly. You should see
Okay.
the vast majority of fossils having more carbon 14 on the outside, less on the inside.
Well, so let me throw out there real quick, because I feel like everybody watching this who disagrees are going to think we just kind of passed over their evidence for the old Earth, which is radiometric dating. How would
Yeah,
you
and
respond?
actually, I think the broader evidence for an old Earth is not the dating itself. It's the fact that, we've studied a lot of radioactive isotopes and we've measured a lot of half-lives. And if I look at the radioactive isotopes that have short half-lives on the order of 1,000 years or 10,000 years, if I look at those, we don't find any of those isotopes on Earth unless they have a renewal process. The Earth renews its carbon 14, so there's a new renewal process like that. But for the other short-lived isotopes, they're gone, right? However, if the Earth is only thousands of years old, there should be plenty of them around, right?
Yeah.
On the other hand, we do find a lot of radioactive isotopes that have half-lives on the order of 100 million years. Now, those should still exist in a billion years or so. So in the end, we do find the right pattern for an old Earth. Longer-lived isotopes are more plentiful than younger-lived isotopes. So that's the broader view.
Okay.
And I think that's a fairly reasonable argument. I think like any scientific theory, you have to stack evidence. And I think there's so much more evidence for the young Earth that evidence is overweighed. And so I think there's probably some other reason we don't see that. But nevertheless, that's probably their most and most old Earth advocates don't know this.
Yeah.
These are just the people who actually know the science.
Well, and I think talking to people about creation in general, there is this need that people have on the creation side to not be willing to admit there is any evidence to the other position when that's not necessary. There could be things that make sense in their position. That's fine. The question is which has the more overwhelming evidence for it, though, which is better, right?
Right.
Not which is
honestly,
exclusive.
right. And honestly, it's both sides do this.
Yes.
Not just you're saying, and I agree, there are a lot of young earthers who say there's absolutely no evidence for an old Earth at all. That's false. But there are a lot of old earthers who say there's absolutely no evidence for a young Earth at all. And that's false as well.
Correct.
And I think that's one reason it's hard to find scientists who will go against the consensus here, because in the end, it's all a weighing game. When you look at the evidence, you have to say, well, and not only which has more evidence, but which has the better evidence. And oftentimes, whether you not or you believe in the theory depends on which evidence you think is better.
Okay. Now, you brought it up earlier. You mentioned in talking about why people tend to believe in evolution, I think the first group of people, you mentioned the flood, actually, and how even if you found Noah's Ark on top of a mountain, you would still conclude it's impossible to have a worldwide flood. Is a worldwide flood really that impossible?
No, I don't think so. I think it's left a lot of evidence behind. I mean, when we mapped out the Atlantic Ocean and found this big fissure going down the center of the Atlantic Ocean, that to me is striking, imagery of the fountains of the deep opening up, right? And so I think it's left its mark on the Earth, and far from being impossible, it seems to explain the bulk of the geological data better than a world without a global flood. Now, I'm certainly not a geologist, so there are other scientists who are better at talking about this than I am. But nevertheless, if you look at lots of aspects of geology, there's sort of a mystery if there wasn't a worldwide flood. Like, we have these sedimentary rocks, and sedimentary rocks have to be laid down by water or wind or something like that. We have these sedimentary deposits that are as bigger than Canada, you know?
Wow.
And that means sediment had to be carried by water over
Yeah.
an area that's bigger than Canada. How do you do that with a calmly flowing river or something like that? You were talking about massive of sediment movement, which tends to mean massive water movement.
Well, let me push back an objection that I've heard. And that objection is okay, if there was a worldwide flood, where did all the water go?
Yeah, well, I think what most people who make that argument don't understand is that Earth's topography has never been stagnant. I mean, one thing geology tells us is that the earth changes a lot. We can watch, over time, mountains eroding and getting smaller, getting shorter, and things like that. And we can find islands forming. There wasn't an island there last year. Now there's an island because of some underground volcanic eruption. So we know the topography of the earth changes, and I think in a worldwide flood scenario, you start with a world that is much less uneven than it is today.
Mm-hmm.
So the mountains are shorter, the valleys are not as deep, and so forth. And so when you cover the world with that water, you're covering smaller mountains and filling in shallower valleys.
Yes.
When the continents move and they create these big fissures which deepen the oceans, then there's plenty of place for that water to drain into.
Okay.
And when the continental shelves build up, then they will rise out of the water. So I think people are trying to use the wrong topography of the pre-flood world to try and understand that. Yeah, there's not enough water around to cover Mount Everest as we see it today, but that wasn't the kind of mountains they had back then.
Now, you mentioned the continent splitting off. So there are different camps in creationism, in young Earth creationism specifically. And I think for the most part, it's started to consolidate around, and I'll ask you to give a little detail on it, around Baumgartner's theory, I
Yes.
want to say is where it's mostly consolidated to, but there are still people who push back against the idea of a supercontinent. Do you think that is something that is clear that was there in the past, or is that a reasonable debate still?
I don't think, any scientific debate is in some level reasonable because science is very tentative. But like, for example, if you look at what would be the west coast of Africa and the east coast of South America, not only do they fit together as puzzle pieces, if you look at the rock sequences, they're the same.
Hmm.
The same thicknesses, the same sequence. It really does look like a landmass was broken into.
Yeah.
Now there could be other explanations for it, but to me, here's the strongest evidence that that kind of movement has happened in the past. Maybe not for a supercontinent, but that the continents are moving. We can put GPS receivers in a building, and we can ask the GPS receiver, keep telling me the position of that building relative to this line of longitude, and it'll keep telling you over a period of a few years, you'll see that building move a couple of centimeters.
Hmm.
And over 10 years, you'll see it move 10 centimeters.
Wow.
because the building is moving because the continent is built on is moving. We
Yes.
can track these things now. And so NASA, the JPL Jet Propulsion Laboratory, has a website you can go to that just shows you what these stationary GPS receivers are doing, and they are moving. And if you plot out their movements, what you see is exactly what plate tectonics says is supposed to be the motion of the plates. And the motion of the plates is supposed to have what riven the what broke up the supercontinent. So I think there's the geological evidence, but I also think we know the continents move. There's no question about that. Whether they were all together at one point, I don't know. But since the GPS can constantly get me to my destination, I'm going to believe the GPS that the continents are actually moving.
Now, so you don't think the idea of affirming Pangea type supercontinent is just giving evolution something? It's not affirming evolution in some way.
Yeah. Okay. So one thing I will say is, as a scientist, I don't look at theories as whether I'm giving my opponent something or not. I try to look at the data, right?
Yeah.
I remember I was in a creation evolution debate, and someone in the question and answer session brought up the footprints in the Paluxy River.
Oh, yeah.
And I said, look, those aren't really human footprints. There's
Yeah.
lots of reasons not to believe it. And afterwards, one of the creationists said, you can't give that evolutionist anything. You gave him a point that way. I was like, no, I gave truth a point.
Yeah.
Right?
No, no.
So
I
so I don't look at it that way. But now what was the question?
Pangea.
Oh yeah, okay. But actually, I think Pangea, it was actually inspired by a young Earth creationist. Certainly, the first scientific description of continental drift came from a creationist, not
Oh.
an evolutionist. And it's because, what does the Bible say? I think you don't have to be this hyper literal, but nevertheless hyper literal. The Bible says God created the land,
Mm-hmm.
not the lands. That kind of implies land was all in one place. And that's why he did the whole continental drift thing. Now he actually had data too. It wasn't just the scripture.
But it's supported.
Yeah, but it supported. So I think actually Pangea is at least more consistent with the Bible than the continents being separated to begin with.
Okay. Can you give, 30, 60 seconds? I don't know how you do that, but that's going to be on you to figure it out. The method for the world flooding. So Baumgartner's theory, which I'm assuming, would it be fair to say that's what you think is the best theory right now? Would be
Yeah, it's
John
the best
Baumgartner's
working
theory.
theory.
Okay.
Yeah.
Could you explain just briefly how that works? How the continents go from not flooding to not flooding again?
In Baumgartner's view, the fountains of the deep play the biggest role. Most of us, when we think about the flood, we think of the rain falling for 40 days and 40 nights being the driving force of the flood, and that probably produced a lot of water. But the majority of the water in the flood came from below the crust of the earth. And so as God caused the fountains of the deep to erupt, what he was doing was taking water that was stored under the crust. And we know there's water stored under the crust. It's not formed liquid water, but it's there. We still see that today. We can find the minerals that have this water content in them. So we know there's a lot under there, that he took that water from below the crust and he thrust it up through the crust to make the fountains of the deep. But of course, when that happens, when the water thrusts up, it's got to thrust up through the crust, so the crust has to break, and then that thrust is going to push the crust apart.
Okay.
So wherever the fountains of the deep erupt, you're going to have the bottom of the ocean splitting apart, and so that's going to carry the continents in different ways. And so that's the quick reason. That's why the continents are moving.
Now, can you give just one piece of evidence? What do you think is the best evidence that there had to have been a flood?
If you're talking about the best piece of scientific evidence, I
Yes.
think you can find layers of rock that are perfectly melded into each other. So, like there's the in the Grand Canyon, there's a layer of, I can't remember the two names of the layers, but there's a layer of rock that just blends into the next layer of rock. But according to standard geology, those rocks layers formed with about 100 million years in between.
Oh,
So if there was 100 million years in between, the bottom layer should have been eroded, and then the top layer formed right on top,
got it.
right? But what we see, and this isn't just one-off cases, this is everywhere. You see these rock layers, which the old Earth version of geology says, there was a few 100 million years in between their formation, but they blend in together perfectly. That makes no sense. If they were both transported as sediment to the same place, it would make sense that they blend in
Yeah.
perfectly.
Yeah.
So that's called a paraconformity. A paraconformity is there should be a separation there, but there's not.
Got it.
And so every time in geology you read paraconformity, that's special pleading for an old Earth.
And so that ends up being evidence for a flood. And
Because
yeah. So as we wrap it up here, if somebody's watching and they want to learn more, they want to get better at defending their faith, equipping themselves, or just answering questions for themselves, maybe they're on the fence and don't know exactly what to believe. What do you think are the best resources on creation?
Well, honestly, I think these days the best resources are found in the websites of the major organizations. So I typically, when I need to bone up on something, I go to creation.com and put in their search engine what I need to remember or what I need to bone up on. And I get, 10 articles written by knowledgeable scientists about that particular subject. And that's what I go. If you're worried about, where did the dinosaurs fit in the Bible? Go to creation.com and type that in their search box. If you have specific questions, if you're wanting to defend your faith, though, if this is for people who are wanting to either buttress their faith or learn more about these, if you're wanting to defend your faith, I don't think the way to do it is to try and find articles or resources that support your faith. I think the way to do it is to learn whatever subject you're really trying to use to defend the faith, and then use your knowledge in that subject. Because a lot of Christian apologists think, well, if I can read a lot of Lee Strobel and I can read a lot of Institute for Creation Research stuff, then I'll know everything that's out there and I can defend the faith. I disagree with that, because there are going to be huge gaps in your knowledge.
Yeah.
And so it's much easier to defend the faith in a particular area if you know that area.
And this is what you were saying earlier. Instead of getting a degree in apologetics, just go get a degree in geology if you want to defend the flood, and then you'll be much better fit to do that. So do you think it would be fair to say, if you're just looking for reassuring and grounding yourself, it's good to study everything in the sense of a 10,000 foot overview of those subjects? But if you want to go out and engage in a serious way, you need to really learn the kind of base of all of that subject.
Absolutely.
Yeah. Okay.
So, it used to be very common especially the wealthy in England who had all sorts of time. It used to be very common for every intellectual gentleman to have read widely on science.
Mm-hmm.
So they could just talk about, but they didn't have much depth to it.
Yeah.
Right. I think Christians ought to be like that with everything, not just science, but with theology. I don't think Christians should become theologians, but we should know how theology works. We should have read enough theology to know what the basic views in theology are and so forth. So I think becoming widely read is a good way to buttress your faith, because what C.S. Lewis said is an atheist can never be too careful of his reading. Because the more you read, the more it lines up with Christianity. So be a broad reader, and that's the best way to just buttress your faith.
Yes.
And then if you have specific questions, go to those websites and ask those questions to the search box. Don't ask ChatGPT.
Hey, you can ask it to edit an email you need to send if you want to make sure the grammar's good. But actually, in some of the podcasts, you can program ChatGPT to be on the screen and debate you on subjects. And so we've done that a few times. It's actually really entertaining. And it's a weird, it's a fun way to try to see how you are on a subject,
Yeah.
because ChatGPT simultaneously knows way more than you and it is also wrong sometimes. So it's finding that balance. So if people want to know more about a specific subject, creation.com, that's Creation Ministries International's website.
Yeah.
And then if they want to learn more about you, Google you, YouTube you, you got a website, blog,
Yeah,
what's
well,
out there?
so I've got my own website called drwile.com, drwile.com, and you can get to my blog where
Okay.
I haven't been as active on it as I used to be, but I blog about, more recent discoveries in
Cool.
science and history and so forth. Or if you want to learn about my curriculum, you go to bereanbuilders.com.
Okay. Well, we appreciate you coming on this show. Thank you for talking and giving us some of the evidence for creation. So, drwile.com is the website. Berean Builders, if you're a homeschool family, especially, go check that out. We've used that curriculum in private schools. I've used his older curriculum before Berean Builders myself when I was homeschooled. So, go check out his resources. Dr. Wile, thank you for joining us.
My pleasure. I had a great time.